Hello, this is Ms. DB, and in this lesson we're going to talk about perimeter and area in the coordinate plane. So we're going to be putting these figures on the XY axis and then figuring out perimeter and area from that point. We will be using the distance formula for this and also slope of lines. So remember that the distance formula is given by the difference in the x coordinates plus the difference in the y coordinates, and you square each of those and then you add them and you take the square root of that. This is really just the Pythagorean theorem, so you could also use Pythagorean theorem on these. And slope is rise over run, which is the difference in the y variables over the difference in the x variables. If you need to review either of these, look on page 44 and 182 of your book to see how to do those problems. We've been using especially the distance formula quite a bit over the last couple chapters, so you probably have that memorized, or at least how you would do that. Alright, so we're going to be given vertices that are coordinates, and depending on how many there are, that will determine if it's a triangle or a quadrilateral or a pentagon or what it is. So of course you're going to have to draw these. You could put these in Sketchpad. I would recommend putting them in Sketchpad because then the tools in Sketchpad, you can measure the length of segments and you can double check what you find with your distance formula. But you can also draw it by hand. The worksheet will have these graphs on there. It's pretty easy in Word to draw lines, straight lines. It's a little bit time consuming though. If you want to print the worksheets and draw them, that's fine too. So we'll start by drawing the parallelogram. That's easy enough. You put your coordinates in, you connect the points in the order that they give you the letters. Now it looks like this is a parallelogram, but we don't know for sure unless the opposite sides have equal slopes, because in a parallelogram opposite sides are parallel, which means they have equal slopes. So you have to actually check that because you don't know what formula to use. Like if this is a kite, it's a different area formula than if it's a parallelogram. So first we're going to check if that's a parallelogram. We find the slope of EF is negative 1/3. Slope of GH is negative 1/3. Slope of FG is 2/3. Slope of HE is 2/3. Therefore, it is a parallelogram. Okay, so since it is a parallelogram, it means opposite sides are congruent. So we can use the distance formula to find the length of each side, and we only have to do it for two sides because the opposite sides will be congruent to that. So the perimeter is found by adding up all four sides. There'll be 2 of the square roots of 10, 2 of the square roots of 13, so we add those together and we get 2 times the square root of 10 plus 2 times the square root of 13. Now you can do that on your calculator and get a decimal approximation, but you don't have to. Now, the area of a parallelogram, I need the picture again. The area of a parallelogram is given by base times height, but we are not given the height of this. So we found the square root of 10 and the square root of 13 by using the distance formula. If we call the square root of 13 the base, the height would have to be perpendicular to this. So you could find that and you could figure out what the height of that is by using another distance formula. But you could also say, well, doesn't this look like two triangles? Let me see, how did they draw their triangles? Right here, right here. I think they divided them right here. So you can see that the perimeter is just you add all 4 of those sides up. Actually, this should be 13 and this should be 10. This doesn't, oh yes, this would be good. Okay, so if you divide your 2 triangles up this way, this would be the base of each of them, which is 3. 1, 2, 3 units, and the height is perpendicular to the base and up to the other vertice. So these are the heights. Also, it looks like those 2 triangles are congruent, but okay, so 1/2 base times height is the area of a triangle. So we'd have 1/2, the base is 3, and the height is also 1, 2, 3. So one of your triangles is 4.5, 9 divided by 2. And the other triangle, 1, 2, 3, 1, 2, 3. It's the same, height and base are the same. So we do have two congruent triangles. So the area of this parallelogram is 9. So we got that we checked the slopes, opposite sides were parallel, so it's a parallelogram. Found the distance of each side, found the perimeter, and then we found that the area of the parallelogram is 9. So it was easier in this case to use the fact that there's two triangles there than it was to use the area of a parallelogram formula. Okay, here's another one. This one has 1, 2, 3. This is also a quadrilateral, but we don't know what kind of quadrilateral it is. So we draw it out and we say, looks like a parallelogram again to me. I can tell that HL and JK are parallel because they're both vertical lines. So we really only have to check HJ and LK. And they both have 2/5 of their slope. So this indeed is a parallelogram. And now you have to find the area of it. Let's see. If we use this as the base, because area of a parallelogram is base times height, if we use this as the base, then the height is perpendicular to it. We could use that. So 1, 2, 3, 4. So the height would be 5, and the base is 1, 2, 3, 4, also 5. So it looks to me like the area of this is 25. Oh, the perimeter we're supposed to find too. So to do the perimeter, you have to use the distance formula. So those slanted sides are the square root of 29. And the other side we already measured, the bases were 5. So we have 2 of those, 2 of each of those. So 2 times square root of 9 plus 2 times 5 is approximately 20.8. And now they're using, they divide into 2 triangles, but we already found that the area is going to be 25 by using the parallelogram formula. So more than one way to do these, sometimes many ways. Okay, this one says to find the area of the polygon with vertices A, B, C, D. Again, it's a polygon, and it looks like this time it's a quadrilateral. Now this is another way you can do these. You can keep it the way it is, and actually this one wouldn't be that bad, because you could divide it into 2 triangles, and that would be the base, and the height is 3. So this would not be bad doing it directly. But they're saying you could also draw a rectangle around it, and you could subtract out this triangle, this triangle, this triangle, and this triangle. So that's another way you can subtract things. It's just another option. You don't on the worksheet you can do any method that you think is best, but this is one way that you could do it. The rectangle area is really easy to find because it's just base times height. So it's 8 times 6, 48. And then we're going to subtract the triangles in order to find the area of the remaining polygon that's in the middle. This is especially good if you don't know if you have a parallelogram or any random quadrilateral, because you don't have a formula for every kind of quadrilateral. So the area of this triangle up here would be, let me erase that, would be 1/2 base times height. And I'll use this as the base, 1, 2, 3. And this is the height, 1, 2, 3, 4, 5, 6. So 1/2 of 3 times 6 is 9. And over here, this triangle would be 1/2 base times height. So 1, 2, 3 by 2. So 1/2 of 2 times 3 is 3. And this one over here is the same thing, 1, 2, 3 by 2. So that's 6. Half of that is 3. So I've got 9, 3, 3. I bet this one's 9, huh? 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is 9. So if I take 48 minus 9 minus 9 minus 3 minus 3, I would have the area of the remaining quadrilateral. So what is that? 18, 19, 20, 21, 22, 23, 24. So 48 minus 24 is 24. So that's another tool that you could use to find the area of a quadrilateral is you could subtract. Now, see, that's going to be especially important in this one because it doesn't even look like it's a trapezoid, so we have no formula to find that area. So the best way to go about this one is to draw a rectangle about it. And then we're going to find the area of each triangle, which are easy to find because they're little right triangles, and the base is given just by counting one side, and the height is given by counting the other side. And we'll subtract, those four will all be different this time. And then the remaining piece will be what the quadrilateral in the middle is. So in this case, this was kind of the only way to go about this, other than dividing up your original figure into triangles, which you could have also done. So the area of the purple rectangle is 96. So we start with that, and then we start subtracting. Okay, so the first triangle, I'll do this upper right one, is height is 8, and the base is 6. So 1/2, 8 times 6, that one's 24. And then this little tiny one, 1, 2 by 2, is only an area of 2. And this one down here, that's a height of 2 and a base of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 2. So this one has an area of 10 because 2 times 10 divided by 2. And then this one has 1, 2, 3, 4 by 2, 3, 4, 5, 6. So this one has an area of 12. So if we add all these, so we're going to take 96 minus all of those. Or you could add them up and subtract from 96. And you get 48 units left. Okay, find the area in the perimeter. So on this one, we're going to graph those points. So here's -1, or 1, -2 would be right here. 4, 1, 2, 3, -1, 0. Then we connect them with segments. It's kind of sloppy. Whoops. Go back. And then we find, if we have to find the perimeter, we're going to need to know the length of each segment, so we'll have to do that. Let's also check and see if this is a parallelogram. So the slope of this one over here, this line here, is a rise of 1, 2, and a run of 2. So this one has a slope of -2 over 2, or -1. This one has a slope of down 2 and over 2. So this one also has a slope of -1. So these two slopes are the same. Over here, this one has a slope of 1, 2, 3 of a rise, and 1, 2, 3 for a run. Is that right, or did I count that wrong? 1, 2, 3, 1, no. So that one has a slope of 1. And this one has a slope of 1. Because it's the same. 1, 2, 3, 1, 2, 3. So this is actually a rectangle because these lines would be perpendicular to each other. But that doesn't really matter because we don't know the distance right now. So we need to find the length next. Now that we've determined this is indeed a parallelogram, it's actually a rectangle because opposite sides are also perpendicular to each other. So we use either Pythagorean theorem or the distance formula to find the length of each segment. Since it is a rectangle, opposite sides will be congruent, so we only have to find 2 of the sides. So let's find, I didn't label these. This was T, U, V, W. Let's find VU first. So the length of VU would be, I'll use the distance formula. You would subtract the x coordinates, so 4 minus 2, and square that, and you would add the difference of the y coordinates, 1 minus 3, and square that. So 4 minus 2 is 2, so we have 2 squared, plus 1 minus 3 is -2 squared. So we have 4 plus -2 squared is also 4, so we get the square root of 8. which simplifies to 2 square root of 2 if you want. So we got that for VU and WT. So 2 square root of 2. If we're going to try to find our perimeter, we'll have 2 of those, which would be 4 square root of 2. Okay, then the opposite sides, we would have the square root. T is 1, negative 2, and U was 4, 1. So we'll subtract our x-coordinates, 4 minus 1, and square that. And we'll subtract the y-coordinates, 1 minus negative 2, and square that. So 4 minus 1 is 3 squared. 1 minus a negative 2 is the same as 1 plus 2, so that's also 3 squared. So we get the square root of 9 plus 9, or the square root of 18. That can be written as 9 times 2, or square root of 9 times square root of 2, so this simplifies to 3 square root of 2. So I've got 2 of those because the opposite side is the same, and that would be 6 square root of 2. So my perimeter is found by adding 4 times square root of 2 plus 6 square root of 2, which is equal to 10 square root of 2. Because they're both square roots of 2, you can add them together. So this is my perimeter. Now my area, we could divide it into 2 triangles and so on, but the area of a rectangle is equal to base times height, and I found those. It's equal to 2 square root of 2 times, that was like side VU, and the other side was 3 square root of 2. So I can multiply these together and get that this would be 6 times square root of 2 times square root of 2 is 2. Square root of 4, but it's 2. So the area of this rectangle should be 12. Now let's see if we get that same thing if we did it a different way. Let's divide it differently so we can do it without having to... Here, let's do this. We could find this triangle, and this triangle. Let's see if we still get 12. So this triangle over here would be a base of 1, 2, 3, and a height of 2. So 1/2, 3 times 2 is 3. Now let's check this one. This one had a base of 3 and a height of 3. So 1/2, 3 times 3. That would be 4.5. And then this one would have a base of 1, 2. Oh, did I do this one wrong? 1, 2. Oh yeah, that's not going to work. The reason it's not going to work is because, why can't I erase this? Is because my triangle did not go right to that point. See, it's actually not a base of 3, it's a base of a little bit more than 3, and I don't have that exact amount because I'm not sure where that crosses. So this isn't going to work. So the best way to do this one then is to do the formula for a rectangle or a parallelogram as base times height. And since we know that this is perpendicular because the slopes are opposite, so we know it's a rectangle, I can use this for the height, which was the 2 square root of 2, and this for the base, which was the 3 square root of 2. That's really the only way to do this one. I mean, you could try to break it up into triangles, but we don't know. We'd have to find the exact point that intersects to make a triangle, and that's more work than it's worth. All right, so this problem may have been on your homework, so now you know the answer to it and how to find it. Thank you very much and have a wonderful day.